You doing like somebody else now?
Alright, you guys notice all of this was supposed to I don't care who said you what. You can't be quiet, quiet, vanish to the back of the room. Those people who can't be quiet got moved. So at least you're not talking in my ear. It doesn't matter. Go. Alright, so we're going to talk about energy. Now, energy is a topic that you guys should have talked about in another science class. You Sean, is there a reason you're packing up like you're leaving? Oh, you're leaving? Oh, okay, well good. You got your notes out so that you can participate with us for 20 minutes or so? Oh, good. Then at least sit down. Great. Now, we can see energy as dark. How do we see energy? Right now, Jeremiah, just what you correct. Anytime I put notes on the board, you answer that question always. If I put notes on the board, I always how you write that word. All right. Wait a minute. Shorten the word just like. Okay. We see energy as light. All right. We hear energy as thunder. All right. TV, thunder are all examples of. Starts with an S. Sound. Okay. We hear energy as sound. Hold on for.
Yeah, everybody got their own.
Right, the same the way it's up, right? You're taking notes. You're taking notes. And one time Jeremiah said, hold up and go on. I'm done. All right, are we caught up now, Younger? All right, so we can feel energy as what? Any ideas? Huh? All right, if someone shocks you, yes, you would certainly feel that. Yeah. Huh? Jeremiah. I'm not really looking for that. Now, I can put electricity here, and there's nothing wrong with putting electricity there. But there's a whole other topic that we're going to study that can go here. It's one of the things that some of you complain about when you come in the room. Cold. Not calling it cold. The opposite. Okay? You feel energy as heat. Okay? That's the major one that I wanted there was heat. Now, we use energy when we do what?
Everything.
All right, when we what? Work out. Walk.
Good. Good.
Okay? What? Now, for those of us who just asked me again what we're supposed to do with those two sheets I gave you, the one that I wrote 1 through 7, the one that I wrote 1 through 7 at the top of on the math sheet, you have to do number 1 through 7 on. Those are the math review for IMA, AMA, and efficiency. On the other worksheet, most of that is power, work, and just the types of simple machines. You have to review there also. All right, you have to do all of that sheet. They are a grade tomorrow when you get here, yes. Can you what? No. Now, You just went to the bathroom.
I said hard.
Now you're throwing paper at me. Go ahead. Go ahead. Go ahead. All right, does everybody have it? All right, so what is energy? Does anybody know? It is the ability to do work. No. Is the ability to do work. Now, we have a test tomorrow on work. So what is the definition for work? Force acting through a distance. All right, it's force acting through a distance. All right? So, in order for us to use energy, we have to do work. So, think about the definition that you wrote down for work. Can you use energy if you don't move? No. So some of you said, I used energy when I was sleeping. Energy when we're sleeping.
You have to be actually doing something.
You have to do something that does work. So,
Like throwing a baseball.
so, Cynthia, hush. Cynthia, Rachel, stop. So, the second question on your review sheet said, what were the two requirements to do work? So, what were the two requirements? The force and the distance had to be in the same direction. So, if you're carrying a baby or a box and you're walking around with it, are you doing any work? No. Yes, if you're throwing something, you're doing work. So you will use energy. Okay? If it, I don't want it. I want them together. Both sheets together. I've already said this multiple times. If an object does work, it must use what? It has to use energy. You cannot do work without using energy. So, if I can't do work without using energy, what do you suppose the unit for energy is going to be when I calculate this Tuesday? Because I know we have time on Monday. What? Joules. All right, so we got joules and watts. One of them is going to be right. What's the unit watts for, first of all? Power. What's the unit joules for? Work. Which one is energy the same as? Work. So what's the energy for or the unit for energy going to be? Going to be joule. Alright? Going to be J for joule. The unit for energy is going to be joule. Okay? I just want to see what is. I just want to see what I have there.
I go YouTube.
Have a good day. All right, do we have it? So, what are some examples of energy being used? Devin said throwing a baseball. Okay. I don't take shorthand. All right, so lifting weight. Okay. All right, walking upstairs. All of those are great examples of energy being used. Any issues with those three examples? All right, all of them do work. All of them use energy. Now, on your review sheet, did any of you get to the parts where it had like A through E and it asked you if work was being done? like pushing the return key down on the computer. What'd y'all say to that one? That's right. You're moving a distance, and the force is in the same direction as the distance. So that is a yes answer. Not all of them were no's. What were some of the other ones? What was one of the other
The
ones?
man that lifts the groceries and sets them on the counter, that's a no. And the man that lifts the box and groceries and walks in the
All right, lifting them and setting them on the counter is, that's a yes. That's just up and down. So that's yes. That force and direction are going to be the same because that is a up and down motion, and the direction and the force is the same. Now, if he just carried them, that's a no. All right, what else did you have?
You throw a baseball 20 meters across.
That's a yes.
And then as you work with this nation,
Okay.
then there you stay up all night and study with the guy.
Okay.
Your favorite person down the road is not you you stay up for a nap hour in the freezing cold.
That's a no. Okay. All right. Now, the law of conservation of energy. You talked about the law of conservation, probably in elementary school. And I know you did.
They're like, oh, you're not gonna remember this, so we're not teaching you.
Okay, you learned that in middle school, even if you had a sub. All right. Energy is not created or destroyed. It's transferred.
ATP.
Stop an ATP. Now, we're going to talk about two different types of energy transfers, maybe tomorrow, but most likely next week. We're going to talk about kinetic and potential. Anybody remember talking about kinetic and potential energy from middle school? Most people usually remember those two. Maybe elementary school? How about another science class here? Yeah. Okay, that's good. I'll take it. All right. Anybody remember what kinetic energy is?
Yeah.
Okay. Got it. What is it? Most people remember.
Oh, kinetic energy? I know what it is. I know what it is.
What is it? What's
And then light energy.
Hold on, that's all. Hang on. It's energy due to its movement. That's kinetic. Potential is what is it? Most people have it's like stored energy. But I'm going to change that definition because I don't like it. Yes, we'll talk about that in a little while. All right, that's the type of energy we're going to talk about shortly. Now, we're going to talk about kinetic to potential.
Ms. Long,
Yes, ma'am.
can you send Haley Cruz to the office to sign out, please?
I will.
Thank you.
Welcome. She does not need an escort. She's fine. Do you need help getting to the office? I didn't think so. All right. So kinetic to potential is one. They're on YouTube now. All right. And the second type that we're going to talk about is things like Abigail mentioned a minute ago, except we're going to call it Alright, the vast majority of you have a cell phone, right? I'm sure. Now, your cell phone has electromagnetic energy. Because they do. We're going to talk about that in a minute. Part of what you're going to work on. And it becomes what kind of energy? It becomes permanent. It gets hot after a while. Alright? Now, electromagnetic energy is a very broad area that goes from being electrical and anything involving light to heat. All right? Over time, things that are plugged into an electrical outlet will get warm. All right? Now, we don't all keep our phones plugged in, but all of our phones have what in them? A battery, and because they have a battery, they will get warm over time. Okay? There's nothing we can do about that. That just happens. Okay? What? What? Yes. Your phone is what right now? It's cold? Yeah, and it typically stays cold. Most of the time, they don't get really warm unless they're either been overcharged or, yeah, you're on it a lot. And then they'll get warm. Oh, I'm going back, sorry. So we what? Alright. Everybody got it?
Yeah.
Alright, so tomorrow after the test, you're gonna need to get a laptop to be able to work on this. So, you need to write down the 5 types of energy you're gonna have to look up. Well, no, you are. So, after the test tomorrow, like what? Yeah. Yeah. Plutonium would be an example of nuclear energy. So, after the test tomorrow, when you give me the test, I'm going to hand you a graphic organizer, and you're going to go get a laptop. You're going to have to fill in a table with some information. In Canvas, are you listening? Because I'm not going to give you all this information. I'm going to give you this while people are taking the test tomorrow. You should be able to get there at this point, but I will double check. Let me put a note on my computer so that I can do that. All right. Now, so in Canvas tomorrow, I have 2 websites in there that will give you the information you need on these 5 types of energy. There are lots of other types of energy that we can talk about, but we're not going to because they're not relative to the curriculum that you're required to know about. Okay? These 5 types are what we have to know about, and then we're going to branch out into kinetic and potential energy next week. Now, we're getting very close to finishing the math that you'll have to calculate. This has 3 formulas, and then I think we're down maybe to only 3 left, and we're done with the math after this unit. We'll have 3 formulas to go, and then we'll be done. So if you take the math, we're getting close.
I actually learned my math. I learned my actual math class. Hey, I learned.
This fall, next semester I have Mr. Pfeiffer, and
Hey, look, you don't know how to teach me.
Now, if you have a calculator, I need you to vote. What's our homework? I ain't got no homework. Your review sheet. You need to study for the test. Get my calculators. Some of them are